We're going to see how to use synthetic division to factor a polynomial function. So here's the problem in front of us. We're given x plus 5 and we're asked to figure out whether or not that is one of the factors of our function. And if it is, then we're going to use that fact along with synthetic division to further factor the function. So what does all that mean? Well, first of all, if x plus 5 is a factor of our function, that means that there is something that we can multiply x plus 5 by in order to get our function. That's what it means to be a factor. So we're going to use synthetic division to even answer that first question. If we can divide x plus 5 into our function, and if it goes evenly with no remainder, then we know that x plus 5 is indeed a function. So first step is going to be to divide our function by x plus 5, and we will use synthetic division. So with synthetic division, we need to write our division symbol, and then we're going to write what we're going to divide by, and remember that's the constant term except written with the opposite sign. And then underneath our division symbol, we write all the coefficients in order of our function. We want to make sure our powers are all lined up from biggest to smallest, and indeed they are. So we start with the x cubed term, and its coefficient is 1. And then the 8x squared, the coefficient is 8. 11x, the coefficient is 11. And then finally our constant term. Now let's start our synthetic division process here. So the first step is we simply bring down the first number. Then we're going to multiply this by our negative 5. And then we're going to add vertically. And then once again we multiply 3 times a negative 5. And then we add vertically. And then we multiply negative 4 times negative 5. And then finally our last add. Notice that the very last number that we wrote down, and recall that the very last number is going to be a remainder. We have a remainder of 0. This means that x plus 5 will divide into our function evenly with nothing left over. So yes, x plus 5 is a factor. So since x plus 5 is a factor, what we can multiply it by in order to get our function is the result of our synthetic division. Now recall when we write this down, of course 0 is our remainder, and then as we move to the left, we have our constant term, and then moving over, we have our x term, and then our x squared term. So if we write this, we get x squared plus 3x minus 4. So now we have two factors, x plus 5 times x squared plus 3x minus 4. We know that's going to give us our function. Now we're supposed to use synthetic division to factor the function, and in fact we've already done that. So we really just have one more question to ask. We want to know if we have fully factored our function. So recall that when you're factoring, you always want to take a look at each one of your factors and see if it can be factored any farther. We know we can't factor the x plus 5 any farther, but we may be able to factor the x squared plus 3x minus 4. So let's give that a shot. Can we factor that? And recall one of the methods that we learned for factoring, if you have a coefficient of 1 for your x squared term, then you can use this handy little method. So you take the last term, the constant term, and you try to find two numbers that will multiply together to get that last term. And then you look at the coefficient of your middle term, and using those same two numbers, you ask if they will add up to 3. So thinking about it for a minute, I can see that the numbers 1 negative 1, let's say, and 4 will multiply out to give me a negative 4, and when I add them, they are also going to add up to a positive 3. So I have just factored my expression here, so x plus 4 times x minus 1. You use the two numbers that you just got to fill in the blanks. All right, so now we have factored our x squared plus 3x minus 4. Let's go back and let's write our final answer. We're now going to have three factors. We have our x plus 5, which we started with, and then our x squared plus 3x minus 4 we broke down farther into x plus 4 times x minus 1. And now we have completely factored our function.